Hello, my name is Andre. I'd like to welcome you to today's session on live capture and replay with the Migration Assistant for OpenSearch. We'll be using the Traffic Capture Proxy and Replayer packaged in the Migration Assistant to perform a zero-downtime migration from Elasticsearch 8 to OpenSearch 2. In the last two sessions, Tanner walked through deployment and configuration, and Michaela walked through performing metadata and backfill migration. To follow along in today's session, it'll be assumed you have a baseline understanding of the Migration Assistant, including familiarity with deploying, accessing the Migration Console, and historical backfill from the previous sessions. At the end of this session, you'll have a better understanding on how to perform a zero-downtime migration with the Migration Assistant, along with a deeper understanding of live traffic capture and replay, along with transformations. Let's take a look at the application we are migrating today. We have a movie search application written in TypeScript that connects to an Elasticsearch 8 cluster, all hosted in Kubernetes. We can search for a given movie, let's say Harry Potter, and we get the top 10 search results over the cluster. We can also look for something like Star, and we see Star Wars, Star Trek, and other relevant results. This is using full text search over the title, overview, and other fields, combined with popularity. This is pulled from the full TMDB movie dataset and loaded into Elasticsearch 8. We also have Locus configured for application testing and verification. Throughout several points in this migration, we'll refer back to this to see if we had any failures and any changes in latency. This locus is configured to call the application backend for both movie ingestion as well as movie searches. The code for this demo application is hosted on my GitHub repo. Let's look at the steps involved with this migration through the architecture overview of the Migration Assistant. The one here is showing the client traffic that is directly hitting the source cluster, which is the Elasticsearch 8 cluster hosted in Kubernetes. In this case, the client traffic is the Next.js backend that is configured to call Elasticsearch directly. The two here will be our first step, which is switch over of the client traffic from the source cluster to our capture proxies. The capture proxy will capture those HTTP requests in Kafka while forwarding them to the source cluster and returning back the response. At this point, we will take a snapshot of the source cluster with our migration console and use that snapshot in our reindex from snapshot workers to backfill our target OpenSearch 2 cluster hosted in Amazon OpenSearch service. At this point, we will enable the replayer, which will pull the captured traffic from Kafka and replay it onto the target cluster, applying any transformations. This ensures we have no gap in data between the Elasticsearch cluster and the OpenSearch cluster after the point in time the snapshot was taken. This also allows us to verify the behavior of the OpenSearch cluster matches expectations for our search and ingest traffic. We will use Amazon CloudWatch and EFS with our application to verify that these hold and our application is behaving correctly on OpenSearch. Step 6 here is where we cut over the client traffic over to the OpenSearch cluster, bypassing the migration infrastructure. We deployed the Migration Assistant with the AWS Solutions Library for this demo. We'll briefly go over how we deployed, but for a deeper look, I encourage you to view our earlier session where Tanner walked through deployment steps and configuration options in detail. We deployed and launched using an existing VPC. We deployed in the same VPC that both our target cluster as well as the source cluster and backend application are deployed in. For some of the configuration, we can see the CDK context here, which is the file that defines the deployment options that our CDK pulls from. Here you can see our endpoint for the Amazon OpenSearch service target cluster, authorization listed here. Certainly password could be used in a secret, which is what we encourage for production use cases. The source cluster here is the K8 hosted Elasticsearch cluster. Its version is 8.17, and it again is using basic auth with those credentials listed here. We have deployed in the same VPC, and that VPC ID is listed here, as well as enabled reindex from snapshot service, traffic replayer service, and the capture proxy service. With the capture proxy, we've also disabled capturing our health checks from our ALB. Let's perform application switchover. So this is taking the client traffic, which is currently calling the Elasticsearch cluster, to instead call that Elasticsearch cluster through our capture proxy. This will enable us to capture the incoming HTTP requests and responses into our Kafka stream, which we will later use to replay and ensure no data loss happens between the point in time of the initial snapshot and the cutover that occurs. You can see our locus setup has been consistently running, and this will enable us to monitor any changes. As well, if we go through the Elasticsearch cluster load balancer, you can see we have incoming traffic via that locus call. And going to the load balancer of our capture proxy, we can see no requests are currently going through. Now we'll first do a sanity check on the capture proxy. Now some of this is validated in the health checks that the capture proxy operates on, but we can do a quick check just to make sure everything is working, as well as perform any ad hoc tests. So here in the migration console, let's perform a couple tests just to make sure everything looks good before switchover. So we'll run a quick connection check. This is showing that we, on the migration console, can successfully connect to the source and target cluster, and we are detecting the source cluster as 8.17 and the target cluster as 2.19. So this is Elasticsearch 8.17 and 2.19 as expected. And let's also do a quick check just to make sure the capture proxy can correctly connect to the source cluster. So using that endpoint from the ALB that we just saw, I can construct a curl request with application credentials, and I can see that that is working as expected. And also I can construct a curl request without the credentials, and I see it is rejected as expected. Again, I'm using the -K here to ignore cert validation, since again, we did not upload a trusted cert. And that concludes our validation portion. We're now ready to finally switch our application to the capture proxy endpoint. So here is a Helm upgrade command that does just that. It sets the Elasticsearch URL of the internal client to be the ALB endpoint for the capture proxy. So with that, we've migrated the application to the capture proxy, and let's go check at the metrics. You can see that we have had 0 failures during the shift. Over here, we can see a slight latency increase that our capture proxy has added. This is expected because we have an extra hop to the capture proxy, as well as capturing that traffic to Kafka adds some latency in the request. We can see here we went from the low 40s to the low 50s on milliseconds for our P50. This is as expected to have a 10 millisecond hit with using the capture proxy. Now going over to the capture proxy dashboard, We can see traffic coming through. So everything is working and we have completed switchover. Now that we've completed switchover, we are ready for our next step of historical migration. The first thing that we want to do is prep our environment for our snapshot. So what we want to do is minimize the amount of overlap between the Kafka topic and our snapshot. We want some overlap, which guarantees that all records are captured either in the snapshot or in our Kafka. But we don't want too much because this increases the overall time, complexity, and cost of the migration. Within our migration console, we can check the Kafka records. And this shows over 74,000 records. Now this encompasses the requests from the point in time of switchover onwards that our client is sending to the capture proxy, but also requests from before that point, from when we did ad hoc checks and health checks. It would be expensive to keep all of this, and then when we replay, we have to go through all of those records again, even though we don't need them all. To simplify this, we can actually delete our Kafka topic, and this will minimize the overlap that we have. An alternative to this is to move the commit offset that the replayer uses up to the present moment. This might be useful if you want to save this data for later replay or investigation. But in this case, we're not going to reference back to this traffic, so we can clear the topic. Going back to describing our topic, we can see we have less than 1,000 records. And that completes clearing Kafka. Now we can take our snapshot and move forward with historical migration. Again, we'll give more detail for this in our earlier session on historical backfill, but I'll go through this quickly as it is needed for our migration today. Now we are running metadata evaluate. This will return back all the indices, component templates, and index templates that exist on our source cluster. You can see we have a lot. Elasticsearch versions, especially those with XPack or post-fork versions, will include a lot of extra templates and indices based on the plugins that are installed. In this case, we don't actually need to migrate any of these, nor the component templates. The only index we care about is the movies index. So we're going to run migrate, and we are going to skip all of those additional indices and just migrate the one that we need. So I'll run metadata migrate, and I'll pass a few parameters. So first I'll pass the index allow list, then I'll pass the component template allow list. And passing none to these signifies that we don't want any of the indices. It'll look for the text none. If you wanted to pass a list of indexes to be allowed, you can pass a comma separated list here. So we have no issues. And we can see that our movies index was migrated. Within our cat indices, we can see that we have this movies index created. And on the source cluster, we can also see the movies index with 974,000 records at over 350 megabytes. And as we make the call again, we can see that our count has increased. So 282, class 3 to 321. And even though these records are not included in our snapshot, they are captured in our Kafka topic. So when we go through the replay, even though our backfill may not include these, we will end up with those records in here that will be replayed. And now we can start backfill. And this will take a couple minutes, so we'll be back after this finishes. Now that it's been a few minutes, we can check on backfill. And we can see that out of 3 work items, all 3 are completed and none remain. So we can stop backfill. And now when we check our cat indices, we can see out of our source cluster, the movies index has 974,000 records. And out of our target cluster, we have just under 974,000. So again, this completes backfill. The remaining few records we will catch with replay. We're now ready to start the replayer. Again, we go back to the migration console. We can run console replay start, and we have started the replayer. We'll come back in a couple minutes to look at the data. It's been a few minutes, so let's check on the replayer. We can go to our CloudWatch dashboard. Now here, we see the proxy traffic data. We see the replayer data start to come in. And scrolling down a bit, we have our status code analysis. So this is what tells us at a high level if the replayer is working. So it compares the request and response status codes of the replayer versus what we captured. We don't see any data here on matches. So we'll go to mismatches, and you can see one data point here. And zooming in a bit, we can see that we had 1,914 post requests the replayer replayed. These were captured at a 2xx status code, so maybe a 200 or 201 from the capture proxy. And we can see here that the replayer, after replaying, that it got a 4xx status code. So this is something we'll want to look into because this is certainly unexpected behavior for the replayer, and we might have to apply a custom transformation to get these requests to work with our target cluster. Let's look a bit deeper at why these were failing. Let's go back to the migration console. So with here, we have access to the replayer logs. So first I want to find out which replayer we have running. If I run that console Kafka describe consumer groups, we see the current offset, the log end offset, but what we're looking for here is this host ID. Now we can go to the replayer logs. This is in the shared logs output, traffic replayer default. And within here, we want to navigate to the log group that corresponds with our currently running replayer based on the host name. If we had multiple replayer stops and restarts, you'd see more folders in here. But for now, we can go to the matching one, which is the only one. And here we get an overview of a couple of the high-level logs that we include in our EFS volume. So first simply is the logs that our replayer has. These are similar to the logs that we also publish to CloudWatch, just here in EFS for different analysis. We also have long-running activity. You can think of this as traces within the replayer. So it gives us more of a debuggability from an engineering standpoint. And then more high-level logs that are relevant for customers is the progress and tuple logs. The progress is more of a high-level progress tracker for all the requests that the replayer has, whereas the tuples goes deeper into each message and we get the actual full source and full responses that the capture proxy had as well as the replayer. So first, let's go into the progress logs and see if we can find some of these 4xx requests. So you can see a number of files here. These currently rotate every minute. These are compressed, it's .gz, compressed logs. So we can't just normally cat it. We have to use a utility called zcat. So we run zcat. And here I'll just get the last few records. So I'm going to take the last file and I am going to pipe it into tail. And we see the last several records. So we can see There is one put for a put doc, and we can see several posts for search. Now, piecing apart this, the first information item here is the timestamp that we replayed this request. The next is the ID for this request, and we have a more specific identifier. So we have a numeric ID and a specific UUID for the connection, as well as a request index on that connection. And then we have the timestamp that this request occurred on the source. So you can see here, it occurred at 0340, whereas we replayed it at 0346, so 6 minutes later. And the next bit of information that's important is this 201 and these status codes. So this is saying that the request originally had a 201 status code on the source, so this would be .created, whereas the request on the replayer is receiving a 406 response from the OpenSearch cluster. So this certainly is a bit unexpected, and we can look further into why this request got a 406, and all of them. So we can take the request identifier, and we can go to the tuple folder. So here again, similar to the progress logs, we have per minute logs of the tuples. You could search a bit more specific, taking just the minute or a series of time. But for the purposes here, I'll just go through all of the files and search for our identifier. So I'm using zcat along with grep to find the record. And this finds the request that we are looking for. So I can print this with JQ, and we can see the request. If this was a much longer request, we could also use less to paginate through the output, but here we'll scroll through. So we have the source request. This is the request as it was captured by the capture proxy. We have the source response. So this is the response as captured by the capture proxy. So we have the headers of the response. We have the status code. We also inject the response time milliseconds as observed by the capture proxy. So this is the time it took to receive the response. And we see the response payload. Now, target request is similar, though we might have transformations that apply. In this case, the authorization header is actually different on the target request versus closer to the top on the source request. These are different authorization headers because the password has changed and the replayer rewrote that. And over with the target response, we start to get an indication of why these requests failed. So we can see status code 406, not acceptable. And in the payload, we can specifically see that the content type header, application vnd.elasticsearch JSON, compatible with 8, is not supported. This is something that's common in post-fork clients. So this is Elasticsearch clients post 7.10, so 7.11 and onwards. Will have this behavior oftentimes where they send a content type that is not application JSON. It's a special Elasticsearch content type that indicates the version compatibility of the client. And this content type header is not compatible with OpenSearch, and it causes the request to fail. So what we want to do on the target request is write a transformation to make this compatible with OpenSearch. So specifically, we see that this content type and this accept header say application vnd.elasticsearch JSON, compatible with 8, same with accept. And we want to write a transformation that'll change this to just be application JSON. And The body of this request is actually completely compatible with OpenSearch, along with the request URI and other fields. So we can go back to write this transformation, and we have a framework in JavaScript for this. Now we'll be covering this a bit more detail in a later session, but for the purpose of this video, I've already written the transformation that we need. So I have it in a file transformation JSON. So this is a transformation format that we accept into the replayer. So you can see this is a list of transforms, and the type of this transform is a JSON JavaScript transformation provider. And the meat of the transformation is an initialization script, which is a TypeScript file. And to see this a bit more easily, I have this raw transformation. And so you can see a bit clearer what the JavaScript is actually doing. So here we get the headers from the request. We get the accept header. If it's an array, we map our Elasticsearch specific application type to application JSON. And same with content type. So relatively simple. And this transformation is all that we need for the replayer. So to apply this transformation, we want to tell the replayer to use this transformation. Let's add our transformation file. So here we have the traffic replayer extra arguments. Within here, we'll add a transformer config file argument, and we can point to our JSON transformation that we intend to use. And now we've deployed. So the next time we'll come back, we'll restart the replayer and we'll verify that this transformation works. Now that our deployment is finished, we can start the replayer. Going back to our migration console, we can run console replay start. And now our replayer has been started. Let's wait a minute and get the new data with this replayer that has a transformation applied. Now that it's been a couple minutes, we can check the logs. Again, we can see which of our replayers is running. And our Kafka consumer group tells us it's the replayer ending in 10428. And navigating to the shared logs directory, we can go to the progress logs and we can get the last of them. And we can see here on these requests, they were a 200 status code on the source and a 200 status code on the target. Let's do that again just to see if we can verify that the doc puts are also working. So I can get whole directory. I can grab for doc. Actually, I'll grab for put, and I'll get just a few. And we can see with these, we are getting a 201 on the source and a 201 on the target. We can also verify if any of these were not 201, 201, and we don't get any. So we can see all our doc puts succeeded and all of our searches, at least the ones we saw, succeeded. So let's look a bit closer at one of these successful doc puts. So we can take one of these IDs and again go to the tuples directory, search for that ID, and we can see that again we have the source request as expected, source response. Now here on the target request, if we go down to the content type, you can see that this has been changed based on that transformation we applied. And then again, you can see that this succeeded on our to cluster. Going over to the dashboards, we can scroll down, and now within our status code matches, we are seeing all of the 200 succeed, And on mismatches, we aren't seeing any records. So this is good and as expected. Now that we've fixed the replayer with the transformation and have made sure that all the status codes look good, we are ready to restart our migration with this transformation. Now, if we continued the migration as is and waited for the replayer to catch up, we actually have an issue that those first requests that were retried 4 times and failed, we don't actually retry those with this transformation. So we could get around this by backing up our Kafka topic, the consumer group for the replayer, back to the first record. This would have the replayer replay those initial requests. And in this case, that would actually work since all of the mutating requests are idempotent. But in some workloads, there is an ordering that is important for these requests. And to maintain a more consistent order, one thing that we can do now that we have finalized this migration setup is that we can rerun some of the steps. So going back to the migration console, I'll perform those. So first I'll stop the replayer, and then I'll perform other cleanup steps. So I need to delete the snapshot. I need to clear the target cluster. And now that this has worked, let me just verify that the target cluster does not have any records. And I can see there are a few records on the movie's index. This must be from the replayer still shutting down. So I'll clear the target cluster again, and we can see that the target cluster is fully cleared. If we checked, we could see the replayer is stopped now. And likewise, we will reset Kafka and go through the steps again. So I'll run my snapshot, and this is after I have cleared Kafka. I will run my metadata command once this is finished. So success, run my metadata command, and I'll start backfill. And I'll come back in a couple of minutes when this is done. We're back. Let's check our backfill. We can see again that we have all the work items complete. We can stop backfill. And now we can start the replayer, knowing that we have applied our transformation for correct conversion. We've given some time for our replayer to catch up, and now let's look at the logs. First, we have the lag in minutes. This represents the time between a request being captured and a request being replayed. So we can see this starts at 4.5 minutes and goes all the way down to 0. You can also see our speed up factor. This is how fast the replayer is replaying requests compared to the capturing on the source. So this set to 1.5 means within 60 seconds of the replayer, we have actually replayed 90 seconds worth of data that we have captured. And people always ask us how long until we have caught up the target cluster. So we built this graph, time to catch up in hours. And this shows that we started with about 6 minutes until we have caught up. Especially for longer migrations, this can give you a good sign of when to come back. And as far as tuning this goes, we've deployed with a cap on the speedup factor of 1.5 in our deployment. So if the overall system could handle a higher rate, that can certainly be tuned up, and that will contribute to a shorter time to catch up. Now we can check our clusters that they're in sync. And we can see here on the source, we have 984,245 docs on the movie's index. On the target cluster, we see we have same number, one more. This can be due to differences in time between the refreshes. So we can just do this one more time. And again, we have the same exact count on the source and target. Again, if this number of docs being ingested was very frequent, you might never see an exact match due to the difference in timings as those requests get replayed. And that's where the dashboards can help you to show that you are caught up. Now that we are caught up, we have shown step 4 and 5 in this diagram, and we are ready for final client cutover. Let's perform cutover. So this is step 6 in this diagram. This is showing where we want to send the client traffic now directly to the OpenSearch cluster, now that both the Elasticsearch 8 source cluster and the OpenSearch 2 target cluster are in sync. So going over to our application, in order to do this, we have a new client within our backend. So as we saw earlier, we needed a transformation to get the request to work. So we know that if we just shifted the URL on our existing clients, they would not be compatible with the OpenSearch cluster. And so we've developed a parallel path within our migration that is triggered by this OpenSearch value. And by setting this, we will have our client use the OpenSearch JavaScript library to call the OpenSearch cluster with these parameters. So with the set, we'll deploy this, and we'll give a minute for this to deploy. We're back, and it's been a few minutes since we deployed. We can go to our locus setup and verify this migration. So you can see here for the entire duration, we have not seen any failures. And we can actually see on our response time, since we did that deployment to the OpenSearch cluster, we've actually seen a reduction in latency from the Elasticsearch 8 cluster, self-managed in Kubernetes, to our OpenSearch cluster. So this is showing roughly a 15 to 20 millisecond improvement. We've given CloudWatch some time to update. And again, going down to our process bytes, we can see that this has going down to basically 0. So there might be some health checks that still call this, but other than that, the traffic has been migrated. And again, back to our locus configuration, you can see that decrease in latency. And throughout this entire duration, there have been no failures. And we can search for star. And as expected, we see Star Wars, Star Trek, and the other results. And with that, we have completed our migration with Migration Assistant. Today, we have successfully completed a migration from Elasticsearch 8, self-hosted on EKS, to OpenSearch 2 with our movie search application. We've done this with zero downtime, using the Migration Assistant capabilities for historical backfill and live data migration. And we've learned a bit about transformations in the process with the replayer. I hope you all have enjoyed this session, and we hope to see you at the next time for a deeper look at the other parts of Migration Assistant. Bye for now.